Hi, I'm Andy, and welcome to episode 2 of Real Garage. Previously on Real Garage, we did some rust repair on the front floor pans of our Trans Am. Today, we'll be opening up the stock wheel wells and installing a set of mini tubs to fit the fat shoes that this beast needs to hug the road. I decided to use a set of tubs from Detroit Speed instead of forming my own like we would on some race car builds, because I still want it to be stock appearing and functional. These are already formed complete with templates and instructions. It would take me the better part of a day to roll and form just one of these. So for the money, these are a valuable time saver. We'll also check out a Real Scoop segment on cutting equipment, as well as a Real Gear segment comparing the Multimatic 215 to the Multimatic 220 AC/DC. I like the detailed instructions that come with these. However, I'm going to be using a plasma cutter instead of cutoff wheels for most of my cuts. I feel it's a lot faster, and let's face it, I'm not getting any younger, and I want to get this job done. Before we get to cutting, we need to drill out and remove some spot welds on the inner wheel well and the trunk hinge support. I can honestly say that I hate drilling and cutting out spot welds. The factory spot welds are very inconsistent. Some are deep, some are shallow, some have a couple spot welds, and some look like the spot welder operator's wheels are out of balance. I will drill and cut out the spot welds that I absolutely need to, and then use the plasma cutter to cut the hinge support out, where I can cut the spot welds out later on the bench vise, and then reinstall them after the new tubs are in. You don't want to drill all the way through, you just want to drill through that first layer. Then I use a real thin screwdriver, but this is actually a punching screwdriver, so I can actually hit it with a hammer and not hurt it. So I'll use this sometimes, or they sell what's called a weld buster or a spot weld buster, but I make my own out of old lawnmower blades. It's cool because it's hardened steel. I can sharpen the sides and the ends so I can hit it sideways or from the top, and that helps separate those panels. So now that that's busted out of the way, we're gonna end up fixing this piece, and once we get the new wheel tub in place, we will hammer this back down and re-plug weld these holes onto the new inner mini tub. All right, now that I got that drilled and separated, you'll notice that I did weld some braces in here to keep the hinge in the proper position. Now I can go ahead and plasma cut the rest of the hinge support out. Before we cut out these stock wheel tubs, let's do a Real Scoop segment on metal cutting tools. There are many options for cutting metal, like oxy-fuel, plasma, abrasive wheels, whether on an electric grinder or on an air tool, even electric shears or nibblers, sawzalls, and even some manual snips. There's not one cutting tool that can do it all, and each one of these has a place in my garage. Oxy-fuel is great because it's portable. I can take it to the racetrack, I can take it anywhere really. It doesn't need an electrical source to run. It only needs oxygen and acetylene. I like it because I can heat up thicker materials to bend it or cut it. I also use it to anneal aluminum if I need it to bend easier. And it's great for heating up rusty bolts to remove them. My cutoff wheels are also good, and they serve a place too because I can control the depth of cut with these. Okay? Your abrasive wheels are going to be clumsy when you're trying to get into tight areas, but they also require an electrical source unless you're using an air cutoff wheel or a cordless cutoff wheel. The electric shear is a nice option for cutting thinner materials as well. It's not so good for cutting shapes or corners. It likes to cut straight. If you want to cut shapes or corners with an electric type shear, you're going to need a nibbler. And I'm not a big fan of those because they leave these little kind of toenail looking shear drop off pieces and they get everywhere. So I'm not a big fan of the nibblers, and I will usually revert to my plasma cutter, which is awesome for cutting shapes or straight edges. It's a precision cutting tool, kind of like a laser. So the downside of that is you have to have a smooth hand or use some type of a cutting guide that you can rest the torch on while cutting, and it'll give you an absolute straight cut. So if I was going to be cutting on something like a car, I could just set that torch right on here and it'll give me a perfect cut. So the plasma cutter is excellent for that. When cutting into tight areas, you may want to remove the drag shield, and that will expose the tip. You'll need to put on the deflector shield because that will protect the threads of the cup. Now I can get into tighter areas with that torch and give me a better plasma cut. Okay? When cutting thinner materials with your plasma cutter, make sure you turn that amperage adjustment down to match your material thickness. You don't need to cut at a real high amperage on thinner materials because it only gives you a wider cut, a wider heat effect zone, and it makes it a little harder to control, as well as wear your tips out faster. My Sawzall, another great tool for cutting metal when you're not concerned about depth. Okay, if you're gonna chop a top or do something like that, I'll do that with the Sawzall. Okay, my hand snips, love my hand snips for detailed work. I've got smaller ones for real small detail, and I've got just some general snips as well. Okay, these are great for small detail work where I'm fitting a patch, especially in my floorboards or something like that. I need to cut things to size or trim smaller areas. Okay. So these are kind of the primary tools that I use in my shop. Ultimately, I probably use my hand tools the most, probably because I'm just fitting smaller patches. But when I'm removing things like wheel tubs or cutting out floorboards in cars, the plasma cutter is the way to go. When I'm doing detail cutting jobs, especially where there's multiple layers like the inner liner or outer liner of a body panel, and I only want to remove one piece of that, I'll use the cutoff wheels because I can manage my cutting depth. And remember, read and follow all labels and your owner's manual. Alright, now that I got this plasma cut out, I do want to note that I did use my Spectrum 375 plasma cutter using 120 volt input power. The only reason I did that is because I don't have 240 on this wall right next to where I'm using it. And it's easier to change the plug using the MVP system than to drag out my big heavy 240 volt extension cord. Now I'm going to start working on cutting the inner wheel wells out. Okay, the factory shock mounts do have to come out before I can do any more cutting. They come out pretty easily. I just use a punch, my weld buster that I made, and it does come out pretty easy. I'm also going to take my air grinder with a stainless steel wire brush on it, and I'm going to clean up some of this seam sealer so I get a better plasma cut. Note the marked lines from my template that I already marked inside the car as well as in the trunk area. Those are my cut lines for the larger mini tubs. Before I make those, I'm going to cut the stock wheel well out so that it gives me some additional room to make those other cuts better. I like using the plasma torch without the drag shield on and the deflector shield on in its place, because that allows the tip to stick out farther and gives me more room to get in these tighter areas. Alright, now that I got the stock wheel well out of the way, I can get in here and finish cutting out the trunk pan and the interior areas. It also helps to use a cutting guide for your long straight cuts. Then repeat the process for the other side. I'm actually at a good stopping point to review what I've done so far. And actually, why don't you just walk along with me for a minute and we'll show you. So you can see my plasma cut area turned out pretty good. It's actually quite straight and pretty clean. Might have to clean it up a little bit with my angle grinder. These points here, this lip and this long lip here are going to get bent down at a 90 degrees, so that's where the new wheel tub will get plug welded to. I still have to cut the rest of the frame out. This will get notched out on this side, and I've already got this cut out. And those will get a frame cutout patch made out of 1/8" steel. And it's easy to see that cut area from here. So not a lot of cleanup I'm going to have to do on this. I think it turned out pretty good. So I'll get to fabricating those cutouts and we'll start welding them in. Okay, I'm on the driver's side now and I have this wheel tub fit into place and marked where the plug weld holes need to be. I'll pull it back out, drill or punch those holes, and weld in the frame cutout patches. But before we do that, let's check out a Real Gear segment comparing two multi-process welders to see which one might be right for you. I'm going to do a comparison between the Multimatic 220 AC/DC and the Multimatic 215. The Multimatic 215 can be ordered in two different configurations. It can be ordered as a MIG stick-only machine, but for the purposes of this video, I'm going to be ordering the combo part number 951674, which includes the TIG accessory kit. Let's get these things unboxed so we can go through all the parts and pieces independently and show which one's going to be right for you. So I've got all the parts and pieces for each machine laid out on these tables. I got the Multimatic 220 AC/DC accessories on my left, and on my right I've got the Multimatic 215. On the Multimatic 220 AC/DC, all of these accessories come complete when you order the machine. The big difference I see between these two accessories is, one, the TIG foot pedal for the Multimatic 220 is the standard industrial foot pedal for all the rest of the Miller products. It's big, it's heavy duty, it has a lot of pedal resolution, and it uses the same 14-pin receptacle that's found on the professional grade machines. On the Multimatic 215, it uses this smaller foot pedal to control it when it's in TIG. And it has a RJ45 cord on it, so this machine uses a different type of connector. There is an accessory that you can buy that adapts this RJ45 plug to the 14-pin plug in case you do want to upgrade to the heavier industrial pedal. But as far as the pieces that come with the machine, it looks like the accessories are the same. You get the same TIG torch, you get the same ground cable and stick stinger as the Multimatic 220 has the same ground cable and stick stinger, and I even checked the size of the cables and they're the same as well. So that's part of the accessories that are the same. You get the same MDX 100 MIG gun in both units, and with the Multimatic 215 you get this as the standard regulator in the box with the machine. When you order the TIG accessory package, you do get a slightly different regulator for the TIG setup that has two fittings on both ends. Okay. Slightly different there. With the Multimatic 220, you get two of the same type regulators. Okay. The gas hoses are also the same. So I don't think that makes a difference. The body of the actual regulators look to be the same, but the only difference I see here is that one of them has a barb fitting and the other one has a flare fitting. Other than that, the rest of the accessories are all the same. So I think the big difference here between the two machines, in my eyes, is the fact that the Multimatic 220 includes the industrial foot pedal. And for me, that means a lot, because that means that all the industrial accessories will also work with the Multimatic 220 AC/DC. So let's clear the tables of all the accessories and let's put the machines on the tables and take a look at them. After unboxing the machines and looking at the specifications for each, they both have the same minimum and maximum amperage ranges in all processes, except the Multimatic 220 AC/DC has AC in the TIG mode, as well as DC. The Multimatic 215 only has DC in its TIG mode. Both machines have a similar auto set feature, where you can select a material thickness and the machine will put you in a weldable range and give you an adjustment within that range that doesn't allow you to get outside of a weldable condition. The Multimatic 220 AC/DC also has a unique feature called QuickTech. I could be using the MIG gun and then simply set the MIG gun down, pick up my TIG torch and step on the foot pedal, and the machine will automatically switch processes for me. The Multimatic 215 doesn't have that capability, and again, you have to go to the front of the machine and actually change the process location and possibly even change the leads on the front of the machine. Both machines are capable of running a spool gun. I would recommend the Spoolmate 150 over the Spoolmate 100 only because it's a heavier duty piece, it uses heavier contact tips, which allows you to weld a little thicker material, and it has a longer cable. The Multimatic 215 with the TIG kits runs in at about $800 to $900 less than the Multimatic 220 AC/DC. If you were going to try and compare the two or upgrade your Multimatic 215 to a little heavier duty foot pedal with the adapter cord, you're going to be into that adjustment right there for a few $100s, and that's going to get you closer to the price of this machine. If you're only looking for a MIG stick unit or primarily MIG welding, but you really like the integration of the digital meters and the AutoSet Elite, the Multimatic 215 is an excellent choice because it does give you the ability to adjust that voltage infinitely within the voltage range. If you're looking for 17.2 volts, you can dial that in quite easily with this machine. This is an easy upgrade for me if you're looking at the difference between a Miller-Matic 211 and a Multimatic 215 if you're primarily doing MIG. If you're only going to be doing TIG in the DC mode, the Multimatic 215 also has that great smooth DC inverter TIG arc. The Multimatic 220 AC/DC has that same engine, but it does have an additional inverter engine to give you the AC output. Both machines use the same high quality cast aluminum drive assembly and the same spool hub assembly. Both machines are capable of running on 240 volt or 120 volt input power by using the Miller multi-voltage plug. You can simply change from 240 to 120 by unscrewing the collar, removing one plug, and installing the other. The machine automatically sets itself. So in closing, you're going to have to ask yourself, which machine is right for me? If you're looking for a machine that's just going to be a step up from the, say, standard Miller-Matic 211 type machine, and you're looking for digital meters for more precise control, the Multimatic 215 is an excellent choice. If you're looking to weld aluminum anytime soon, or you're in an industry like motorsports where you're welding multiple materials like aluminum, steels, Inconels, stainless steel, things like that, the Multimatic 220 is an excellent choice. Or if you're just a home DIY guy looking to have a complete welding solution, the Multimatic 220 AC/DC is definitely the way to go. All right, so you can see here is where my marks are. I'm just gonna drill or punch some holes here. I'm gonna space them out about every inch or two. I'll do the same on the top. And I'm just marking the locations for my plug weld holes. I'm going about every 2 inches. They don't have to be perfect because you're gonna grind these down flush anyway. Punching holes. Love punching holes. Not gonna be able to get all of them with the punch. I do have a hand punch. I can knock some of these out, or even a drill. But the punch is way faster. You can make them about any size you want, but you just gotta make sure that the holes are big enough that you can penetrate into the material behind it and then catch this overlapping material. Too big of a hole just means you're gonna have more grinding later on. These are 5/16 holes. Like I said earlier, these don't have to be exact. Just plug welding them and then grinding them back down. This hand punch is just a mini version kind of that Rotex, except you have to change the dies out manually. Has about a throat area of about 2 inches. It's quicker than drilling, that's for sure. And you don't have as big a mess to clean up. Now I'm going to go weld those frame cutout patches. All right, it's time to weld these frame cutout patches in. The patches are made out of 1/8 inch steel, but the material around it is a little bit thinner than that. So I'm setting the Multimatic 220 for the 14 gauge setting. The AutoSet Elite allows me to have a window to adjust that in too. So if I need a little bit more, a little bit less power, I can also make that adjustment. The 14 gauge setting is going to allow me to weld the 1/8 inch material to the little bit thinner material. Plus this is an outside corner weld, so it really doesn't take up as much power as the 1/8 inch setting would give me. So it's plug welding really well. And I'm trying not to put an excessive amount of weld like I did on this one, so I don't have as much to grind off. Another great thing about the Multimatic is the real positive arc starts. It doesn't stumble. You don't get those real high amperage peaks where it burns through the material. It just pops off every time you pull the trigger. So I know what you're thinking. Why are you using a welding helmet for grinding? Well, I'm using the Digital Elite welding helmet, and it has a grind mode, which keeps the welding helmet in its clear state. So I can use it for welding and grinding. Now you're probably going to ask, well, aren't you afraid of grinding sparks getting on your welding helmet? My answer to that is, if I'm not afraid of welding sparks, I'm not afraid of grinding sparks. Yeah, there we go. Patch is all welded in, blended. Now it's time to fit the wheel tub back in place, get it all clamped in, and start plug welding. These tubs do fit kind of tight, so don't be concerned if you have to do a little dance to get these things in here. It does help to have a whole bunch of C-clamps when putting these things in. And then get this thing clamped up, and I'll climb inside of it, put more clamps on it, and then I can start welding. Got this thing pretty much where it needs to be. I'm gonna climb inside of it, put a few spot welds along the top. This is not healthy. All right, I got the inside upper spot welds all in place, and now I'm gonna pop all these in. The ones where I'm spot welding onto the 1/8 inch plate, I'm actually gonna set the machine at the 18 gauge setting. But for the ones that are on the thinner sheet metal inside, I'm setting it for 20 gauge so I don't blow through the back. I also like to take my vice grip to pull the sheet metal together. And I can weld right in between them. Okay, now I got a lot of grinding to do. I grind and blend all these plug welds. Alright, so that wraps up my wheel tub install for today. I didn't fully weld in the passenger side yet because I do need the space over there to install the new coilover shock mounts. Next time on Real Garage, we'll upgrade this beast to the 4-link suspension, do a real road trip, and one of my real projects to help optimize your garage space. So if you like our content, make sure you subscribe.